product demonstration of aPriori. I'm going to cover costing a machine part from billet, a simple assembly, and then taking that billet machine part and switching the billet into a forging. We'll begin with my CAD system on the left and aPriori over here on the right. If you'll notice, whatever I open in the CAD system, it will pop up in aPriori over here on the right. If I'm not connected to a CAD system, I can directly navigate to CAD files. I'll demonstrate that later on. To begin, I've got a part. I need to answer a few questions. First, what we'll do at a high level is choose the process group. Is it sheet metal? Is it casted? Is it machined? I'm going to choose stock machining. Then I need to choose where I want to make it. aPriori has 67 different regions of the globe that I can choose from. Here I have a limited list. I can also configure this to match a specific company. So if you're, whichever you are, I can set your materials, your labor and overhead rates, your special secondary processes. We'll just do aPriori USA. aPriori has a routing engine. What it does is it looks at that machine part, looks at several different ways to machine it, and then chooses the most appropriate. And then I can also add secondary processes here. So if I have specific surface treatments, for example, anodizing, I pick it from a list. If I have inspection, I can pick those from a list and include those. These we can configure to match your environment. So depending on who you are, you'll have different secondaries, different inspection, different things like that. At this point, I'm going to go ahead and hit the cost button. This is happening real time. What we also have here, while this is costing, is I'll discuss the materials database. I have several different materials available to me. These are easy to change. I can put in your materials, your stock forms, your cost per pound or kilogram, and the rates at which you machine those materials. They're pretty easy to update. And then you also have to specify the annual volume for how many years, and then aPriori will choose a batch size. We simply divide the annual volume by 12. And again, this batch size is going to have profound effects on cost. A batch of 1 is going to be far more than a batch of 300. So now the part's done costing. If we come over here and look to the left, under part summary, I've got a lot of real rich, detailed information here. First, we've got rough mass, some high-level information. This is the cost by process. So I've got material, bandsaw, 5-axis mill, mask and bench, anodize, and x-ray, and that's exactly what we chose. What I do want to do is take a look at tolerances. So within the CAD system, if you set a tolerance, aPriori can leverage those. That's a PMI reader, product manufacturing information. So what I'm going to do is just go ahead and pull those tolerances to see what changes, and then I'll update the cost here. If you don't specify the tolerances in the CAD file, we can easily place those in the model right here and then leverage those. So while this is costing, I'll continue with the tour on the desktop. Here I have a cost by category. Over here we've got fully burdened cost. We've calculated a rough mass based on a part envelope. And then we've also got a finished mass so we can look at the material utilization. So now this is done costing. A few things have changed. First of all, the cost has gone up, but based on the tolerances, we've added a drill press or a jig bore because we had a tight tolerance there. We've got a reciprocating surface grinder. If you want to further explore those tolerances, we can go into this Design to Cost tab, and then there's an option here to look at tolerances and finishing operations. When we go in here, what's critical is certain tolerances drove certain operations. So in this case, I've got 4 ream holes. If I go and choose one of those holes, it's going to say the tolerance value is 2 thousandths. If you kick it to 4, or 0.038, we can then get rid of that reamer. There's also some finished boring in there, which you can see here. And then, in addition to that, grinding on this surface. Again, if I drill down, it'll show me the surface, and then what I can change that to avoid that expensive secondary process. If we go in and look at tolerances as a whole, it says it's got some circularity, diametrical tolerances, flatness. These particular tolerances didn't drive new secondary processes, but they would have potentially increased the cycle time on the surface because we had to slow down the feed rate, that type of thing. So all of this has an effect on cost, and we're able to leverage that. If we take a little bit more look at the detail, I have a cost, a fully burdened cost, a breakdown of cost here. I can drill in for more details. So if I go to part details in here, and then under stock machining, we're going to be able to see that the total machine time is 59 minutes. We've got 30 minutes of roughing, 17 minutes of surface finishing, and then hole making. And this gets broken down into even further detail. If I were to, for example, grab a surface on the model, that planar face, and ask exactly what you did there, it'll tell me that I've considered several things, and we landed on facing. It took 77 seconds to make that. And then we go into further detail and look at the process setup options here. We've got one pass with a 3 1/4 inch end mill at 254 surface feet, feeding in an axial feed of 34 inches a minute. We then estimate the time. We will do that for every single surface on the model. Once you've done this costing exercise, which was pretty much just answer the questions over on the left, and then we can generate a cost, you can generate reports from here. So if I go to what a report looks like, it's got all that detail pushed into here. You can then use this to negotiate with the supplier. You've got your annual volume, you've got a picture of your part, material utilization, each of the machines that you used, and the detail on every single one of those machines as well. If we take a look at some more detail in there, this is a high-level view of the routing, and then you can drill down and get more information. So for example, if I want to look at what 5-axis mill did I use, I can choose that. It's going to show me the number of setups, the orientation of those setups over here on the left, and then here's the machine that we used. There's a library of machines. So it chose a 5-axis mill, it then goes to the library of machines, and then chooses the most appropriate 5-axis machine. You can configure this list to match your machines. These are all the manufacturer specs of those machines. The labor and overhead rates are easily changed and configured depending on the region of the globe you're running this, what shop you're running it at, several things. That stuff gets addressed in the virtual production environment. These are very easy to change. So at this point, this was for a supply chain person or someone who's generating a quote. This will serve as your first quote as a negotiating tool. Now what we have is tools for a design engineer. So this will measure the general health of the model. When I go in and pick this, we call this the heat map, it's going to show me or give me several different options of things that I can review. We'll just cover a few. The first one up here is concave surfaces. What this is showing me is that here are the concave radiuses on the part, and what I see here is very good. I've got all my vertical radiuses that would get machined with the side of the tool as one color, and then I got my floor fillets as another color. And then if we flip over to the bottom of the part, you can see some other stuff here. When I see this condition, that means I have 3 radiuses coming together in one corner. This is going to cause problems for when we machine the surface because I'll have to face it and then ball mill it, and I highlight that in other areas. This is a very healthy, good-looking curved surface radius threshold analysis. I've got an example of a bad one. Here is a part with all different size radiuses on it. This means that I'm going to have all the different size end mills to machine this. It's going to be much more difficult to program, all different sizes to inspect. What we want to do is keep that to a minimum. And again, this is what a good, healthy model looks like. We'll also analyze unique hole diameters. So this is going to go in and look at all the different hole diameters in the model, show me the sizes. Again, if you can keep those down to a minimum, you're going to have a easier part to program, easier to inspect, and also a much less expensive part. Other things to consider in here are finish mill operation type. As I had said before, we go to every single surface and determine whether it's faced, side milled, ball milled. That's what you're seeing here. You want to keep things out of this contour mill bucket and out of the general mill finish. General mill finish means there was potentially an issue. But again, we see a lot of facing, a lot of side milling that's less expensive to do than contouring or these unknowns here. Also in here is side mill length to diameter ratios. This is looking at all the side milled surfaces and saying here's how long of a tool you're going to need to make this. The longer the tool gets, the more time it takes to make that. So if you could keep these under 4, you're in good shape. And then finally, we're going to go look at features to review. What this is going to tell me is, hey, you had some real issues in this model. Here we've got a side mill length and diameter that exceeded my max threshold, which was 7 to 1. It highlights those for me. I've got this sharp internal corner right here, sharp corner. It's highlighting where I missed a round, and this is on a wall. And then I got a sharp corner where I missed a round on the floor. And then finally, I talked about contour corner. That's this condition here, where you have to face, and then you got to go in and pick out the corner. This low finish rate just means that you've got some ball milled surfaces in here. So what we want to do is look at, maybe get a little more detail on these. I've got another tab over here which is designed to cost, and it shows me, hey, here's issues to review. This is also where we saw our tolerance stuff. We'll go into issues to review. If I go to side mill length to diameter, those highlight, and then if I need a little more information because I don't understand what it is, I can pick this, and this gives me a description of what a side mill length to diameter violation is. By the same token, I've got sharp corner violations. Down here, it'll highlight that for me and then show me each surface and then give me some more detail as to what the exact violation was. So at this point, we've gone in and looked at some of that information. Also within this design to cost tab, there's a material tab which says, hey, we looked in your database, you have some other materials that are similar to the one you use, there might be one less expensive. Then stock utilization, we can look at the stock fit, update, modify that, review it, and distinct hole diameters. So earlier we looked at all the different hole diameters. This is saying that there's 5 hole diameters that are standard, 1 that's non. What it also does is matches to the drill on the appropriate drill chart. So we've got a number 36, a 3/8 drill, the number of holes drilled with that. So you've got a lot of really good information here. Also, we've got fillet radii. Some are standard, some are non-standard. And you can set the thresholds on what's a standard and what's a non-standard. So by going through these steps, you can generate a relatively healthy model and then move on. So at this point, we've costed a part. We've looked at a product report. What we want to do next is we'll kick over to the non-CAD user side, and then I'll look at an assembly here. So we're now on the non-CAD user side, and here I'm not connected to the CAD system. So this will run standalone, and I can navigate directly to CAD files. Here I've got an assembly CAD file, and I'm going to go ahead and open that up. When I do, it'll take a few moments. It brings it to the screen. Here we can see the part, but I've got some helicoils and some bushings assembled into there. What I want to do is cost this. Once again, I've got some default set as far as where I want to make it. Again, I can choose an alternative region to assemble it in, or I could just keep it in this generic USA facility. It automatically knows that it's an assembly. I want 300 of these things. I'm going to go ahead and cost this. What this will do for me, and granted this is a simple assembly, is break out the assembly into subcomponents. So here I've got my aero mill part, and then I've got some bushings, and then I've got some helicoils. Now I've pre-assigned cost to the bushings and the helicoils, and if you have libraries of hardware, you can upload all that stuff into the system, and then anytime those names appear in subsequent assemblies, you automatically get a cost associated with those. What we'll do next is look at what's actually in the assembly and driving cost, because this A21 is a little higher than the cost to just the part. And that's going to include these, and then some basic assembly cost. And as you can see, there's machining here. Here the basic assembly is just pick and place to load those components in. Now what we want to do is maybe give it a little more detail. So when I go to the components in here, you can see that I've got my bushings right here. Maybe I want to press fit those in. So I can grab those, edit the operation, and under mechanical assembly, simply say we want to press fit those in and include those. Now you can add any types of assembly processes you want here with configuration, but we'll go ahead and put those in. That pick and place will now show up, and then my cost goes up. If I go down and look at what was in the machining, what happened here is I had assembly cuts, and it knew that it had to match bore these right here. So if you put an assembly cut in your CAD system, we've picked it up, we've added a drill press in 2 different setups. What we might also want to do in this assembly is maybe there's welding in here. Although this might not be appropriate, there is a weld tool where I can come in, choose my type of weld, pick the edges that I want to weld, and then I can also add welding into cost. When I recost my model here, we can see that weld costs will then appear in there as well. And finally, you can add high-level assembly processes here also. So if I go to the operation on the top-level assembly, I can go in and edit my routing information. And, for example, maybe add packaging. And again, you can add packaging, logistics, all different types of things like that here as well. So now once I finish up, we'll see that within here we have several tabs under assembly. We've got pick and place for our components, press fitting of the bushings, the mechanical assembly, the welding, the machining of that, and then our other secondary processes, which was packaging. If we go to this cost summary, we'll be able to see that material cost was 0, but then I've got component cost and then the different costs to add or sum up all of this stuff, which was 828. So we've now costed the part itself and then the part with the bushings, helicoils, everything else in. And if you have traditional assemblies of multiple components, you can do that as well and roll up the cost there. Now the last thing I want to do is go back and open that initial part that we costed, AeroMill, and we machined this from billet. So this will come up in just a second. We machined it from billet. We have our cost breakdown here. Here's how much we have in material, labor, overhead. I want to explore maybe if I do this from a forging, what's that going to look like? So I'm going to go out and open up a forged component that I had modeled previously. And this is just a blob that looks more like the part. And what I did was define this thing as a forging. When we open this part, my process group is now forging. I then choose my facility, the annual volume. In this case, I want it to be 300, so I'll override that value and recost, and we'll get a cost for that forging. So again, it's just a matter of opening the part, setting the process group, and then recosting. Here we've kicked it to 300. We've got a bandsaw, preheat, material, hammer, and trim. If I go to my cost summary, you can see that going from 50 parts to 300 dropped the cost by almost more than $100. And then also we've estimated the tooling cost for this as well. And that's just going to include the hammer and the trim and the cost of each of those hard tool components. So we've now got a forging here. What we want to do then is go back to our AeroMill part, and I can save this as multiple scenarios. So we'll do a scenario of this thing, and we'll save it as forge. This will give me an exact knockoff of everything I had in there, but in its own little bucket. I can also change the material that I want in there, the annual volume, and create different scenarios. But in this particular scenario, instead of stock machining it, what we're going to do is two-model machining. And when I do two-model machining, what it's going to do is instead of putting a wrap around there for a piece of stock, it's going to say, what do you want to use for your stock? And that's going to be my forging. So I'll go search that from my database. There it is. And then it'll go in and lay that over the top of the part. Now, again, we'll do it in the USA, or we could choose to do it perhaps in Mexico to see what it's going to cost, and that's the machining. But again, you can select any different virtual production environment and do comparisons. Now, we know that it's going to be a 5-axis mill routing, so we'll go ahead and choose that, and then cost this part. So this will go through, very similar to what we did before, but instead of analyzing it from a piece of square stock, it's going to put that source component in there, and we'll see a different cost because it won't be machining off as much material. The base material might even be less expensive when we did go to a forging. So these tabs will all populate. Again, here we have the reciprocating surface grinder, the mask, the bench, all of that stuff. All of this will get pushed into this model, but instead of using that billet for stock, the square piece, it's going to use that new model. So now this thing is finished costing. If we go and look at our cost summary, we went from 705, which was the stock machined, to billet machine, which is 545. And then we'll go in and have a look at what happened. Under the volume, we can see the source model. We've got a lot less material coming off. We have a material cost of 401 as opposed to 384, so it was a little more expensive to make that forging. But when we were done, there was a lot less machining that had happened on here. Now what I'd like to do is put these things on a side-by-side comparison report where I can get a lot more detail than this. The way I do that is simply do a comparison report, and then I'm going to search for parts with the name Aero in it, and I had two scenarios, a forged and a stock machined. It'll then grab both of those, and now I've got a side-by-side comparison. Here was the stock machined in USA. Here's the two-model machined in Mexico. Or I could also do a version in the USA or in China or wherever I wanted. And then we can see the exact differences in here. And at what point does it become worth it to go to a forging based on the annual volume that I'm running? So with that, we'll conclude the demo. Thank you.